at Mozilla, and he's going to tell you how to run your code on the dark web.
All right, we're going to see how quickly we can do this. So my name's Luke. I'm a privacy and security engineer for Firefox, and I speak really fast, and I have 300 slides. So we're going to go quick. So how to run your code on the dark web, and why you should, because it's not actually a scary dark place. It can be a fun place. It actually is how to write your code for the dark web. That's what we're going to talk about first. And writing your code for the dark web is actually writing your code for Tor. So Tor is a browser. Tor is mostly Firefox. It is a patched version of Firefox with the Onion router. Why is Tor patched Firefox with the Onion router? So let's talk a little bit about the internet and bad things that can happen on it. So if you think about IP and DNS and HTTP, there's all these kinds of threats out there. So hackers in the middle, internet service providers snooping on their customers' activity, governments censoring websites, corporations scanning web logs for their competitors' IP addresses, or criminal sites scanning their web logs for law enforcement IP addresses. So this is an EFF diagram of everything I kind of just said, all the intermediaries that can jump between you and a website. We're going to go into it in detail, and it's a lot to take in. I'm going to start going through it slowly. I'm going to come back to this a lot, and later we'll be going through this really, really fast. One note to make is that in this diagram, it says location. That's going to be equivalent to IP address when it says that. So in this diagram, the first person that can get between you and a site is a man-in-the-middle hacker. They can see the site you're going to. Unencrypted, they can see your user password, data, location. Next up is your ISP, and they can see all of the same things. And then any agencies or departments or nefarious rogue nation states can look at the things between ISPs. The ISP of your site provider can see everything, and then the site itself can see everything. So we use HTTPS to protect the user password and data from all of these intermediaries. So we get back through this diagram now. The hacker in the middle can now see the site you're going to and the IP address you're coming from. Same with your ISP. All the intermediaries between ISPs, the ISP, and then the site you're visiting, again, they have the other side of this HTTPS connection, so they can see everything in the clear. So HTTPS, in terms of those threats that I mentioned, really only addresses this first one of the hackers in the middle, right? And we all kind of understand this, and this is why we love HTTPS. So how do we protect this location data and the destination data from these intermediaries? So the number one go-to thing is usually VPN. You can use a VPN. Some of them are bad. They will kind of sell your data in a anonymized form, or they'll just leak your data because they're bad. The good ones cost money. And this is where we get to one of the first, like, why you should either do this or care about this. There's a great TED Talk by Christopher Soyan called Your Smartphone is a Civic Rights Issue. And he points out that there's now increasingly a gap in the privacy and security of the rich, who can afford devices that secure their data by default, and of the poor, whose devices do very little to protect them. So this is pretty important stuff. So how else can we protect that location and destination data from intermediaries? So like I said, Tor is patched Firefox with the Onion router. So what is this Onion router thing? So this is a diagram from Tor project itself about how the Tor network works. I'm going to kind of hand-wavy this, so if you like the crypto things, there are lots of docs on the Tor project site about it. Otherwise, just ignore that and trust that math works. So step one is we have our eponymous heroes of all security situations, Alice and Bob. Alice wants to connect to Bob's server anonymously. So Alice has a Tor client that she downloads, and it obtains a list of all of the Tor nodes that are out there from a directory server. So now Alice knows about all of these Tor nodes, right? So in this directory server, the Tor nodes are described where they are, and along with the public key of how to communicate securely with that node, right? So Alice's Tor client then picks a random path to the destination server. Her Tor client picks 3 of these nodes that she's going to use to bounce through and eventually get to her destination path, okay? Hand waving over this for a second. If we trust that that works and go back to this diagram now, what our hacker can see is just the IP address and that it's using Tor, nothing else. What your ISP can see is your IP address is using Tor. Your IP address is using Tor. We have these new intermediaries now, though. We have these Tor Relay nodes. So these are the 3 nodes that she connected to. The first one can see her IP address and that she's using Tor. The middle one doesn't get to see either side. This is like a key part of where you break this connection between location and destination, right? The last one can see this traffic is coming from Tor, it's going here with this data. And so then on the ISP side and the site side, they can see the same stuff, right? And then the site, again, sees things in the clear and knows that it came from Tor, not who exactly it came from. So Tor takes care of all of this, right? But since Tor routes through 3 networks, now we're going to start to talk about how this applies to your code, right? The number one thing you can do to help your code run well on the dark web, or at least for Tor clients, is to optimize for latency. So anyone do, the whole optimize, compress your assets, make them really small, bundle them, blah, blah, blah. So there's the good way to do it, and there's the bad way to do it. This is just a graph that shows that page load time as bandwidth increases has this leveling off effect. So as soon as users get about 3 megabits per second, any faster bandwidth doesn't really help them, right? Whereas if you can get latency time down, that just continuously makes sites load faster. So MDN is an example site. I worked on MDN for a long time. That's why I get to make fun of it whenever I want. So this is just a network graph of how much of a page load on MDN is the latency and how much of it is the bandwidth. So you don't need to optimize for this little tiny part, right? That's not the most effective optimization. And some numbers, MDN cached takes half a second or 1.4 seconds. Now, MDN on Tor takes even 4.5 seconds when it's cached, and uncached takes about 12 seconds. So this is actually pretty good for a site that is visited by Tor. If you look at something like Wikipedia, this is the article on North Korea on Wikipedia. And on Firefox itself, the first time you hit it, it's 5 seconds. The next time, it's 4.5 seconds. On Tor, this is really bad. So uncached, it takes 92 seconds to load this page. And cached, it takes 82 seconds. And the main reason here is that MDN only has 21 requests, and Wikipedia makes 70 requests. So minimize the number of your requests, and you should really be doing this anyway, regardless of Tor, right? One of the tricks there, so make fewer, larger asset bundles. 6 is the magic number here. And this is just another article. By the way, I'll have all these slides, so don't worry about furiously taking notes. They'll be on the speaker deck, and they have all the links in there. So yeah, once you get it down to about 6, if you can get your assets down to about 6 requests, that seems to be the magic number. That happens to be the default pipelining limit on Firefox and Chrome, and I think on Edge too. So another way to get rid of some requests is to actually use Css Sprites for images. So instead of having 16 images, you can have one image that has all 16 of those graphics in one image file. And then you can use CSS positioning to kind of move the element itself, the background of the element, to be in the spot that you need it to be in, right? So if anyone's ever used CSS Sprites, you should be familiar with this. There's a great article on CSS tricks to do this. You can use data URIs for really small images. So data URIs are basically just base 64 encoded versions of an image, and you can actually inline them into the page. And I know code isn't showing up well on this monitor, but basically you've got an element and you've styled the background has a URL, and the value of that URL is actually data::image/GIF. and then a semicolon, base 64, and then a big blah, like a big blob of what the actual image is. So in that way, you can basically put images straight in the CSS. You can get those image requests completely out of your code, right? And then something else you can do is use icon fonts for icons. So if you've got really, really small images, don't load a bunch of those. And actually, icon fonts can work better than the sprites, or I'm sorry, the data URI images for this. So you can build your own icon font, and then you can just deliver that as one font for all of the icons that are on your site. So the way that works is essentially you have HTML here, and it says, data icon equals, here's the hex value. And then in your CSS, you say the font family is this icon's font family that I invented, and then the content is this, attribute data icon. So go look at the element and grab that out of the data icon attribute. One other thing you can do is help the browser with resource hints. So this is kind of a new feature out there. On certain links, you can use this rel equals preload when you know, for example, that sprite images are going to be included. It basically goes and will load those before the DOM gets to them. And in the context of Tor, this means that it'll start making those requests earlier, which means the page is going to end up loading faster. So rel equals preload is basically something you can put at the top, and as soon as the engine encounters this, it will make that network request right then. It knows that it's about to load it somewhere else on the page. Rel equals prefetch is you can put this on like a front page, and you can say it's this, a future page is likely going to need this, right? So if you know that the most popular pages on your site are this, then this, you can put rel equals prefetch on your home page to try and speed up the requests to those before they even need it. Rel equals preconnect is when you know that a domain may be contacted. So if you have assets that live on a different domain, or if you have other things that live on a different domain that you're going to include on your page, if you use rel equals preconnect on your home page, it will actually perform like the DNS lookup and the TLS handshake and all that, connection consuming stuff while the user is basically idling on the front page. So that also helps speed up connections. You will have to wait until early next year to do this for Tor. So those features are landing in Firefox. But I'll show in a minute that Tor is actually like kind of a ESR of Firefox. So you have to kind of wait to get the best features. And then one of the last things you can do, you can actually make CDN work with Tor exit nodes. Not all of them will do this. Tor exit nodes, for some reason, do bad things on the internet. I can't imagine why. So Cloudflare CDN will actually allow you to enable it to serve images to Tor exit nodes, but you have to enable it. So they don't want, Tor exit nodes are also what's used to, hack Cloudflare. So if you want to enable it, if you think that you're likely to get Tor users, you can go into your Cloudflare access rules and actually add it. They call it a country, so you can like enable access from the Tor country. Okay, so now your site is faster for Tor users, but your Tor users are going to get hacked, right? So if you remember these Tor relays, and the way that Alice got connected to them is she found their public keys in the directory server. And there's a great video from Khan Academy on how public key cryptography works. So if you want to get into that, that video is amazing. But the way Tor encryption works with a public key cryptography is in this middle pipe, you've got your original data that you're going to be sending to the site. What your client does is it encrypts that data with the last node's key first, right? So the exit node, that key, you encrypt that data, right? Then you take the middle node and you encrypt all of that again, and then you take the first node and you encrypt all of that again, right? So this is how you hide the data from each of the other nodes, and only the exit node gets to see where it needs to send the final request. So the problem here is that exit nodes can see this original data now, right? So now your exit node is your new hacker in the middle, okay? So then everywhere else along the pipe afterwards, you can get hacked. So the exit node threats are just your classic man-in-the-middle threats. There's exit nodes can snoop on the data. Your browser could get hooked with beef, though Tor has a lot of protections for that. Backdoor binaries, malware downloads, that kind of thing. So Mr. Robot, anyone seen it? Not a spoiler, this happens in the first like 30 seconds of the whole show. But he basically explains that that's how he hacks, this person who thinks they're being anonymous on Tor. So what you really need to protect against that is you need Tor and HTTPS to protect location, destination, user password, and data from all of the intermediaries, right? So you should be using HTTPS. Oh my God, you should be using this anyway, right? So if you need help using it, my two favorite tools are Let's Encrypt and its client, Cert Bot. So Cert Bot is a really cool thing for getting certificates either automatically or very quickly and free from Let's Encrypt. This might be kind of hard to see. You can install Cert Bot on a Mac with Brew. You can say, give me the cert, and I want to verify I own the domain via DNS. What domain do you want to verify? Okay, deploy this special text value to your DNS, and then tell us when you do that so we can verify that you actually own this domain. And then they give you a signed cert, and you install it, and you're done. It takes like 5 minutes, it's free. There's no reason not to have HTTPS anymore. I also have, so like I said, these slides will be on speaker deck. I have another one of my talks up there called the top 5. Actually, I'll just give this as a lightning talk too. So the top 5 security errors we see from Firefox. Spoiler alert, use HTTPS is kind of the answer there. And so I talk about HTTPS more and some of the problems you can hit when you deploy it and how to get past those. There's also this cool tool, observatory.mozilla.org, so that you can run scans on your site and you can see, okay, what HTTPS tricks am I using or not using correctly and how to do it best. And then MDN, again, has a really nice web security section. So now on your exit node, they only get to see HTTPS, and everyone else down the chain only gets to see HTTPS. So we're doing good. So now your code is faster and it's more secure for Tor users, but it's also going to be broken in Tor. So like I said, Tor has actually patched Firefox. It's actually the patched Firefox extended support release. So if you go into About in the Tor browser, it'll say that it's, Tor 708 is based on Firefox 52.4.1. So the Firefox extended support release is what we release for like enterprise deployments and people that don't want to make, every single 4 or 5 week jump along with Firefox to a new release. So we have a stable release where we only put the most critical patches into it, right? Tor uses this because they maintain a list of patches on top of Firefox, and maintaining those patches, redoing them every 4 to 6 weeks, that's going to be too much work for them. So you need to make your code work in Firefox ESR. You should really be making your code work in all browsers. You should do this anyway. So step here is just download ESR. If you go to mozilla.org, you can find the extended support release, or you can just search for Firefox extended support release. It has the Firefox dev tools, which has nice little console messages that will yell at you if you're doing things that don't work there. CanIUse.com, who uses this? Really good site. Inside CanIUse, you can actually go up to the compare browsers, and you can say, I want to see like 52 is ESR and 56 is current, so show me what I can and can't use. Like basically the 52 is what you can't use in Tor, and then the 56 is like what you can use in Firefox. MDN has browser compat tables that help here. Kangax.com is a really good site for the JavaScript APIs. It's the equivalent of caniuse.com for JavaScript APIs. And then really the coding tools that are out there, AutoPrefixer, all these things are really nice. They can help you catch these kinds of incompatibilities while you're writing a code. And then there's browsers, CI platforms, Sauce Labs, and Browser Stack. Both include Firefox ESR. So now your code is working for Firefox ESR users, but some of your code is still going to be broken. So why is Tor patched Firefox ESR? And this is where we get into some Tor design and implementations. So Tor has what they do is whenever they implement something, they have this adversary model, and they talk about the goals of the adversary, the capabilities of the adversary in regards to their position on the network, and the capabilities in regards to how they can actually attack. So these adversary models actually guide all these implementations. I'll give you a couple examples, because that's a lot of hand-wavy, like, whoa, what? So they have an adversary model if someone is confiscating a computer, right? Like, okay, let's say someone confiscates a computer, what can we do to protect users from this? And so their implementation of this is just called disk avoidance, right? They just avoid the disk everywhere that they can. So there's a lot of these, like Firefox about config preferences you can do that says only store cache in memory, don't do any index DB, don't download things straight to a file system, all this kind of stuff. So Tor users, that also means that they're going to have to like sign in every time they quit Tor. Everything's going to be gone. So they're going to come back. They're going to have to sign in every single time, something like that. It's just a trade-off they're making. Another example. So here we've got our full model. If someone at the end of this site wants to fingerprint this user, right, and start being able to see every single time they come back, they can do fingerprint. I actually, at last year's ThunderPlains, gave a big talk about fingerprinting, and there's a video out there if you're into fingerprinting. That's pretty cool. But for example, they can use the WebGL card or the WebGL APIs that can access your device hardware, and they can figure out what kind of card you have, and also like what your screen depth is, your resolution, what fonts do you have installed, and that kind of thing. And they can build a fingerprint of your device that way. The Tor implementation to protect this is cross-origin fingerprinting unlinkability, which is a big mouthful of saying they turn a whole bunch of crap off, right? So they minimize the WebGL features. They make everyone look like a Windows 7 user. They disable device sensors. They set the time to UTC time zone. So to really debug your code, what it's going to look like in Tor, just download Tor. All right, it's cool. It's fun. It's not illegal. You're not going to be put on a list, I promise you. And it actually includes Tor dev tools because it is Firefox ESR, which means it has all the Firefox dev tools, which now you have Tor dev tools. So you can open up sites in Tor, and there's a lot of messages that'll come out and just say like, oh, this is what your code does in the Tor browser. But some of your code is still going to be broken in Tor, and one of the reasons here is this is probably impossible to read from there. So this is a hidden service for The Guardian. This is their secure drop instance where they let whistleblowers leak documents online anonymously. And at the very top it says, if you just go to this in a default Tor setup, it says we recommend turning the security slider to high to protect your anonymity, right? So if you actually click the Tor onion button in Tor, you have the security levels that you can set, and it starts out as low by default because most users are just using Tor to be like a little bit anonymous. When you slide it to high, it disables JavaScript by default. It slows JavaScript down to prevent timing attacks, disables MathML. There's no SVG, there's no web fonts. Like, it disables even a lot more stuff, right? Because all of these things have been shown to either fingerprint users or exploit the browser. So no JavaScript. Sorry, I'm at a JavaScript conference telling you that you should not be using JavaScript. But the reason there's no JavaScript, this actually was an active exploit. So we had a malicious site or a malicious hidden service was out there and was actually confiscated. So it was confiscated by, I think it was in a foreign country or something like that. But what they did is they found a memory, basically kind of a memory, use after free type error in the JavaScript engine, which there it is, and it actually says set in B if on Firefox 17, because at the time they did this, Firefox 17 was the ESR, and so they knew that this bug existed in Tor because it existed in Firefox 17. Okay, so the summary for this part is you optimize for latency, make sure it works in Firefox ESR, and then optional without JavaScript, MathML, SVG, web fonts, and all of that stuff. So this stuff is applicable across the clear web, everywhere, right? So you should probably be doing a lot of this stuff anyway. So that's the most applicable part, and now we're gonna get into some funky stuff. So your code works fast and secure for Tor users, but you're gonna get owned if you are the one trying to stay anonymous, right? And now we're finally getting to the dark web. So you can think of it, you have the surface web up here, which is Bing, Google, Wikipedia, all the fun stuff. You have deep web, which is basically everything that's connected to the web but might be behind an authorization wall. Like a lot of corporate intranets are technically connected to the web, but you have to be able to log in to get to them. Research, all this other kind of stuff is out there on the deep web. Basically, the crawlers can't crawl it, right? And then you have the dark web where you have to actually use a specialized client to get to it. So this is Tor and Tor Hidden Services. Another way is at the top, you can turn a computer on. Down the middle, you must be really bored. And last, use a proxy or say hi to the FBI. Okay, so let's go back to this diagram of Tor and HTTPS. And you've got user in the top left here trying to get to a site in the bottom right. And now you are the person running the site here in the bottom right. So how do you set up site.com? And we all know, each computer has their own IP address. It's, forms of strings and numbers. So it's like telephone numbers, right? And then you have DNS, which is domain names. They're human-friendly equivalent of IP addresses. And every domain name is associated with a certain IP address. Well, to get a domain name, you have to go through the resellers who eventually talk to the registrars, who would talk to the registry operators, who talk to ICANN and all this other stuff. And all of their forms are not anonymous, right? There's names, credit card numbers, so you can't use DNS anonymously. So how are you going to set this up? What you need to set up is called site.onion, right? So site.onion is a Tor hidden service, and it uses a rendezvous protocol instead of DNS. I think we have enough time to go a little slow here because this one's many steps. So we have Alice and Bob. Alice is the client trying to connect to Bob's hidden service, and neither one of them wants to know who the other one is, right? So they're going to use Tor network to do this. So step one is now on Bob's side. Bob picks some introduction points in the Tor network and builds his own circuits to them. Now when we say a circuit is one of those 3-hop connections, right? So Bob is not connecting directly to one of these nodes. Bob is making an anonymous connection to one of the nodes, right? So he builds some circuits to introduction points, and then advertises that he's running a hidden service to the distributed database of hidden services, which are there are more relays in the Tor network that have said, yes, I'm willing to give up some disk storage to store a directory of hidden services. So Alice hears that Bob's xyz.onion exists, and she requests more information from that database about how can I connect to this. She also, at the same time, sets up a rendezvous point somewhere in the network. So she's essentially creating her own anonymous connection to some other node that's not one of the introduction points, and she gets to pick it, right? A side note is if you want to find where hidden services are, just go to the r/onion subreddit. Not a big mystery. So Alice writes a message to Bob that's encrypted with Bob's public key, because that's one of the things that Bob publishes when he advertises that he's running a hidden service. And she lists the rendezvous point that she wants to meet Bob at, and she generates a one-time secret, right? And she asks an introduction point of Bob's. She connects to one of his introduction points and says, give this message over to Bob, right? So Bob receives that message that includes the rendezvous point and the one-time secret. He goes over to the rendezvous point and provides the one-time secret to the rendezvous point, and that is sent to Alice, and Alice says, yes, this really is Bob who I wanted to meet and met me at this rendezvous point, right? So now they both have a anonymous circuit connection to the rendezvous point, and they can communicate like normal, right? So all of that happens in like a second or two, right? Because the internet, yay. So now this is what this diagram looks like. It's really, really, really complicated now. But basically all of the same stuff happens, but there are now 6 nodes between Alice and Bob, right? Now, that seems really complicated, but this is actually really easy to set up. You literally, if you're already running some kind of web server, and I'll show you in a second, but you can run any web server on a port. You edit your Tor RC file, which is just a configuration file for Tor, and then you run Tor, and that's it. So this is what it actually looks like. I took the ThunderPlains conference website. It's just a static site, and I ran a Python, simple HTTP server listening on port 8000. I go over to my Tor RC file, and I say, you can add as many of these hidden service directory directives that you want. And I say, okay, store the hidden service stuff in this location at var lib tor hidden service. And I want you to listen, pretend you're listening on port 80, and then forward all that traffic to this 8000 port where the web server is running, okay? And then I just run Tor, and it spits out a lot of this stuff like connecting to the Tor network, blah, blah, blah. And I go over into that folder where I was at, where I told it to store the hidden service items, the config. There's 2 files in here. One is called hostname, and one is my private key for this particular service. So if you just cat on the hostname, you're going to get this garbledygook.onion, right? It's basically a hash of the public key. So it hashes the public key, generates some random 16-character thing, .onion, and then tells the rest of the Tor network, you can find me here now. And now we have ThunderPlains on the dark web. Pretty simple stuff. If you go to this in a Tor browser, you'll see that now the Tor circuit for this site, when I'm at the client, it goes from here to the UK, to some node in France, to some node in France, and then 3 nodes that I don't know where they are, right? But I eventually get to this onion site. So your onion is working, but since your hidden services hop through 6 nodes, you really, really need to optimize for latency if you're running a hidden service, right? So just, again there, minimize your requests, use resource hence, allow CDN access from Tor nodes. But wait a minute, can you use CDN with a Tor hidden service? So this was after a web devs meetup and someone asked me this, and then of course the next couple nights I was like, ooh, can you? So clear web CDN requests can actually reveal the site owner, right? So if you think about the request that's made to a site or to a CDN provider like Max CDN, it includes this referrer header about the site that's making the request. And so if you have an account associated with that particular CDN, then they could say, oh, this person is running this site, right? Because when you sign up for CDNs, right, they have all these forms about like, hey, who are you? So this would not be anonymous, right? If you had a request that was coming from garbledygook.onion and going to your section of a CDN, all of a sudden the CDN knows who's running the hidden service, right? So this was actually a ticket that was filed against Tor a while back. It was fixed about 8 months ago, where they essentially just stripped the referrer to third-party requests, right? Like, we need to stop leaking that these onion hidden services even exist, let alone who they might be associated with. Maybe you can only use public CDNs with a Tor hidden service. So like if it's, jscdn.com, anyone can use that. So could be anybody, right? But probably don't use it. So the advice would just be minimize requests and use resource hence. Probably don't use a CDN. You can still get identified, though, even if you do this part right. There's a tool called Onion Scan. Onion Scan will actually scan hidden services, and it will look for re-identification and de-anonymization vulnerabilities. So for example, I set up our 200OK website as a hidden service and pointed this at it. It found, an in the clear email address, looks pretty, obvious. So you can get yourself anonymous email address. PrivacyTools.io has a good section on anonymous email and encrypted email providers. I like this one called Tutanota because when you sign up, a lot of people use these for spam, so some of them are hard to actually get going if you're not a spammer, but that you can access it via Tor, and then whenever you sign up, you just have to wait 24 hours before you can start sending emails, right? So that's a pretty easy barrier to cross. This one, I don't know what that screenshot is. Ignore that. So you got yourself an anonymous email. You should probably have this anyway. It's kind of fun and cool to have one. We'll get into that. We'll talk more about that later. You still need to use PGP between separate email providers, but you can still get hacked. So one of the other things that it scans for is if there's any images on your site, they can potentially not be anonymous. So this is one of the images that was on the site. But whenever you run, you can look for EXIF data inside of images. And so in this case, this image also contained the latitude and longitude of where it was, right, when we took it. So that showed it was in Tulsa at Central Library. So this information actually, like, I talked to an FBI agent, and they said, like, yeah, that potentially would be something that we would, look into in an investigation, depending on the profile of the case. So you should really strip EXIF data from images. You should probably do this anyway, unless you actually need it, and you have location-free images. you can still get identified, right? Because when we scanned this, I actually saw that we were kind of in the clear just putting like speakers/CaitlinStewart.jpg. And so we just leaked some data that Caitlin Stewart spoke at our conference to potentially, if we were trying to hide that data, maybe we didn't want it to get out, right? So to get around that one, you would obfuscate your upload file names. So anytime you upload file names, you would just make them garbage. This tool has a lot of checks. So you can get into open directories, server fingerprinting. If you leak PGP IDs or your Bitcoin addresses or something like that, they might be somewhere on your site, and that could be used to find you, right? Okay, so some hacks against your users are actually easier on the dark web, and this is kind of the most like exotic, funky thing I found while I was putting together this talk. So phishing on the dark web is kind of interesting from phishing on the clear web. There was, I think, maybe the most pioneering user, or user is a generous term, hacker on the dark web named Crimewave, who essentially spun up a whole bunch of hidden services with addresses that looked like drug market addresses, and then started vandalizing a lot of wikis to actually put their hidden service addresses out there. So what they look like is this. So you've got your drug buyer in the way, way, way top left. You've got your site operator way, way, way in the bottom right. So what they did was basically brute force these onion keys and then run a man-in-the-middle proxy at those addresses, right? And so with a man-in-the-middle proxy, you can do anything you can do with a man-in-the-middle proxy on a server. So let's do that. Anyone remember this story? It broke out kind of like while I was getting into this stuff. So Daily Stormer was a Nazi website that got a lot of heat and was kind of the football of the clear web for a while. People were punting it on and off their servers and things like that. So they moved to the dark web. My dark web. No, I'm just kidding. So they moved to the dark web, and they had this hidden service site for all of their bullcrap. Sorry. Yeah, bullcrap. I didn't swear. Okay, so they're on the dark web, and they have this obnoxious, donate to Nazis via Bitcoin thing on their site, and I don't like that. So I grabbed this tool called Scallion, which is actually a way to brute force lots and lots and lots of Tor Hidden Service key pairs using your GPU instead of your CPU. So I could basically generate about 700 billion hashes in an hour and 41 minutes to get something that looks like their site, and it says, okay, here's the onion, here's the host name, and here's the private key. So then in my Tor RC file, I can go and say, right, I'm going to run this hidden service. It's going to be here. This hidden service is actually a combination of proxy chains, which lets me run this man-in-the-middle proxy tool, but also respond to Tor Hidden Service requests. And then I can say, I want to replace stuff on their site with better stuff for the world. So I have this replace btc.py script that does this, and I can pass it arguments and stuff. So now I have these phishing sites that basically replaces their address with the address of a nonprofit in Africa that teaches tech skills to low-income people. So like that gets to this part. Writing code for the dark web is pretty fun, right? Like you hear talks about dark web, like, oh, dark web, dark web. And it is really cool. It's like really empowering to start messing around with the dark web. But the other thing is that it's also quite practical. Like if you're familiar with web tech and how the internet works and stuff like that, it's 95 to 99% the same tech that we're all used to all the time, right? And it has like this 1% to 5% bit of like, ooh, dark magic on top of it, right? But writing your code for the dark web actually ends up making your code better. So it makes it faster, more secure, more compatible, that kind of thing. And it also makes you think. It makes you think about your privacy, other people's privacy. And then there's this kind of like, isn't the dark web just for criminals? So yeah, there's criminals on the dark web. This is trade route, which amazingly has been like obliterated from the dark web since I put this talk together. But trade route is, your kind of typical darknet market. They sell drugs, they sell hacked databases, that kind of thing. So the content there, yeah, 62% of their stuff is drugs, 25% is digital goods, and then they have fraud services, forgery services, that kind of thing. But really, like, if you all are a statistically representative sample, then kind of like half of you favor legalized marijuana already, even in Oklahoma. So it gets you, how much time do I have? Okay, later. But most of the sites on the dark web are not actually illegal sites. So this is Sarah Jamie Lewis. She maintains OnionScan and actually does these cool like reports on the dark web with OnionScan. So a lot of people are pointing at this IntelliAg and DarkSum reported that like 52% of sites on the dark web have illegal content, but she showed that if you actually like factor out mirrors and other kinds of things, that it's probably, there's 29% duplication rate and at least 10% of the traffic is SSH, which is not legal or illegal. So she says, you know, the amount of crime that's, the criminal sites that are on the dark web is probably a lot lower than that 52% figure. So dark web is not illegal tech. It's not just for criminals. It's neutral tech, right? It's anonymous tech. Clear web sites use the dark web. So this is Facebook on the dark web. This is Facebook core www.i.onion. And they set this up because there are countries and places where Facebook is censored, right? And it's not like you're using Tor always to be anonymous from everyone in the world. Sometimes I'm fine with Facebook knowing who I am because I'm in a different country. I'm okay with Facebook, and in fact, I actually prefer Facebook to my current government. Like, I trust Facebook more than I trust my current government to know who I am, right? So the adversary models are different. This is Proton Mail, so they're one of the encrypted email providers. They run a dark web, or a Tor Hidden Service. This is an anonymous SMS service that runs on Tor Hidden Service, and this is a search engine that runs on a Tor Hidden Service. And then this one is called Secure Drop. I thought I could go through Secure Drop. I'm gonna go through like 2 minutes of it, and we're all gonna like freak out and be, never mind, okay? So Secure Drop is from the Freedom of the Press Foundation, and it is a Tor Hidden Service system for journalists to receive leaked documents and tips from whistleblowers, right? This is his whole purpose in life. This is a directory of all of the like sort of news outlets that have a secure drop system. Associated Press, Bloomberg News, BuzzFeed, some of the other ones, Forbes, Guardian, HuffPost, Intercept, a whole bunch of these have this secure drop server running. So this is the Guardians. You get these nice big buttons. It tells you to set your security slider high. So if you're submitting documents for the first time, click here. If you've already submitted something, click over here. So you say, okay, I'm submitting something new, and it gives you this really long passphrase that you need to write down physically on a piece of paper, right? Because when you come back to this instance, that's the only thing that's going to connect you with anything that you've already done. And then you go through and you submit materials. There's a browse button right there, right? So click it, grab the file that you want to send to the Guardian. This is secure drop behind the scenes, right? So they've got hardware, which involves you have to have your own physical hardware, 2 computers for a secure drop, 1 computer for the admin, the journalist secure viewing station, 2 FI devices, a smartphone or a YubiKey, you need a network firewall, 3 Ethernet cables, lots of USB sticks, and writable CDR disks. All right, just to get you started. On those USB sticks, you're gonna put tails on them, and they're gonna power the viewing station, the admin workstation. Label them immediately so you don't get them confused and plug them in the wrong one. Tails is just an operating system that sends all of its internet traffic through Tor. You can go download it and play with it. Your secure viewing station, you gotta install the USB, air gap it from the internet, which means remove all the other storage, fill all of its other ports with epoxy, and remove any speakers it might have to prevent exfiltration of data by ultrasonic audio. Yes, that's a thing. This transfer device is another USB stick. You have to set it up, you have to encrypt it with a passphrase, and then you have to use CDRs and DVDs because there's this thing called bad USB, where essentially any USB can be reprogrammed to be a different USB device. So even though it's a thumb drive, it may act like a keyboard instead, and it can, as soon as you plug it in, it will start making keyboard commands on your computer. That's not good. So that's why you use CDRs and DVDs instead. And then you generate the submission key, blah, 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 set up your admin workstation, run tails, download secure drop, verify it with all of its keys, set up these firewalls, set up these servers, install secure drops. Oh, okay, you are probably not building secure drop. Okay, it's crazy, but you can respect your user's privacy, right? There's a couple of really good articles. These are the two biggest things to point you at. One is called Privacy by Design on Smashing Magazine. It has a lot of really good principles about how you can think about your user's privacy when you're making things. And this one is Privacy Guidelines for Designing Personalization. So there's this kind of misconception that you can't personalize websites, you can't personalize apps, you can't personalize services without basically knowing everything there is to know about your users. And this article kind of shows you some ways that you can do that, right? And this gets to my clumsy transition to my preachy privacy part that I always have in my talks. There's one article about whose speech is actually chilled by surveillance. And when I read that headline, it connected with me immediately because at last year's ThunderPlains, and I was talking about the fingerprinting talk, Trisha Salas came up to me and said, oh yeah, I've wanted to try Tor, but I heard it puts you on some kind of list and I plan to travel soon, right? So I'm going to put a bunch of other people's smart words in front of you. This is from Glenn Greenwald, who actually broke the Edward Snowden story. He said in a TED talk, he says there's dozens of studies that prove that when somebody knows they're being watched, the behavior they engage in is vastly more conformist and compliant, right? These other quotes may be too long to get into, but in the 18th century, the first time institutions had become so large and centralized, they weren't able to monitor and control each one of their individual members. So this guy, Jeremy Bentham, designed a solution to this that he called the Panopticon, which was designed to be used in prisons. And the primary attribute of it was a huge tower where anyone in the tower could watch all the inmates, but the inmates couldn't see into the Panopticon, into the tower, so they didn't know if they were being watched. And he was so excited about this because it meant that the prisoners would have to assume that they were being watched at any given moment, right? So there's later a philosopher that picks up on this idea and realizes it can be used anywhere, right? Not just prisons. And he said that this framework discovered by Bentham was the key means of controlling people in modern Western democracies that no longer, imprisoned dissidents and did all this other kind of stuff, because the mass surveillance that's out there creates a prison in the mind that you carry around with you that's much more subtle and much more effective than actual prison can really be, right? And then in Data and Goliath, Bruce Schneier kind of explains there's this physiological need that we have for privacy because there's studies that show that mammals in particular don't respond well to surveillance because we feel like it's a physical threat, and animals in the natural world are surveilled by predators, right? So surveillance makes us feel like prey, and it makes surveyors act like predators, right? So you kind of feel, if you feel a little weird or uncomfortable with that, yeah, it is uncomfortable. But if you go download Tor, it helps you break free of that feeling. So I use Tor basically like my private browser now, right? And it feels really cool to use it. And I started to try and unpack why does it feel cool? Like, why does that feel good? And so there's this book called Obfuscation, and they point out that information collection about us takes place in an asymmetrical power relationship, right? So we rarely have a choice as to whether or not we're monitored, what's done with it, and what can be done on the basis of conclusions of our information. And then they have this cool thing in there. One of the benefits of running a Tor Relay, which I do and I suggest you all do, is that it creates this confusion of traffic, right? So like, I ran an exit relay and I'm sure my ISP was like, what the frick is this person doing, right? Because I'm sure it was going to God knows where on the internet, but that also means that it's like obfuscating and hiding my traffic, right? And that feels cool. So there's actually plugins, one's called Track Me Not that sends random search engines, or sends random search strings to search engines just to hide your real search traffic in there, so that's kind of cool. Ad nauseum just basically does uBlock origin, but then it clicks on all the ads in the background, so like all the ad trackers think that I'm into everything from My Little Pony to CrossFit to whatever. And so yeah, it feels cool, and I think that points to this thing that privacy is not just the, oh, I'm scared, I have something to hide, or whatever. There's like this really kind of deep need for us to have privacy, and once you start getting a little bit of it, it feels really cool. And that's why when you see privacy advocates out there and they're like, privacy, it's probably because they caught this bug and they were like, this feels really cool. So that's pretty much my talk. I've done a lot of weird things on Tor, and I've had no problems traveling. So That's it. And I have tricks to make you ask questions. You get a Firefox plushie if you ask a question. If I can throw it to you. Wow, this is a big RAM. All right, so questions? So the one that I specifically showed was running it as a Tor Hidden Service. So I cloned it to my machine. I ran that little Python web server to point at it, and then I access it through there. But you can, I mean, you can access really any site on the clear web you can access through the Tor browser. Holy cow. I should go to a different style of RAM. Oh, James, that's for James. Last I looked, they actually disable HTTP2 as part of the Tor patches because there's, and sometimes it's like unclear about how much of a threat something like HTTP2 is for Tor. And when it's unclear, they err on the side of like, well, we haven't really evaluated if there's, a vector here for someone to identify HTTP2 traffic on our network. So I think last I looked, it was disabled. But Tor is an open source project. You can go on their track and you can kind of see there is an HTTP2. There's specifically a ticket about HTTP2, and I think it's like still an ongoing discussion or something. So the question was, how do you get a SSL certificate for a .onion domain? And the answer is you don't. The Tor Hidden Service protocol actually has its own bilateral cryptographic, oh my gosh, I'm stumbling all, it's just security word salad up here now. But it basically just establishes its own secure connection between the Tor client, or really the Tor proxy on both ends of the connection. So you don't actually have to have SSL when you're using the hidden service protocol. It includes a secure connection. There are suggestions that, like for Facebook, I think they grabbed SSL certificates for their onion addresses because they have infrastructure behind their gateway that like made checks to make sure that the incoming traffic was on SSL. And so they went and did it, but it was mostly about their internal infrastructure needing it, not because the Tor network needs it. So the question was, it has to go through 3 relays to get to a site, and somebody owns 1 relay and they can't see anything, but what if somebody owns all 3 relays? And so this is actually a lot of the first successful attacks against the Tor network, where basically people running enough nodes, especially guard nodes, which are the entry nodes, and exit nodes, because you can correlate connections between them. So you could tell if the same kinds of connections that you saw on your guard nodes were coinciding, like, with whatever the latency delay was in the network with your connections on the exit nodes, then now you know the site they went to and the site that they came from. So this is the basis of a lot of the early successful correlation attacks against Tor network and re-identifying it. The reality now is that in order to do that, you would have to basically buy and run thousands of nodes, which is expensive. And so they also put in place sort of a bad relay marshal type community system that goes out there and checks for exit relays that are trying to hack people and things like that. But for me, the more important part of, and we're kind of close on time. Yeah, I can answer this. Okay. So the more important thing that making it harder to do that with having to buy thousands of nodes kind of points to my thoughts on Tor as a privacy anonymity tool and the sort of security argument that's made, like, oh, well, the FBI needs to be able to see these people that are doing drugs or selling drugs and all this other kind of stuff. And where I've come, where I've rationalized myself probably, is that if it is just like expensive enough for the FBI or the NSA to find me, that's enough. There's no perfect security, there's no perfect anonymity. You can always be found, you can always be hacked, right? The goal of Tor is to make it more expensive and harder to do that. And so whenever I talk to a couple of folks from the FBI about Tor and just the stuff that I'm learning about it and what they do with it and all this other stuff, if I'm doing something to the point where I'm on the FBI's radar, yeah, they should probably come get me. And if a human investigator is actually investigating me, I'm fine with a human adversary. Like, I understand that. There's a human. I did suspicious behavior. Like, they're investigating me. I get that. The thing that really riles me up, or not riles me up, but the core thing that I worry about in the privacy tech space and the online surveillance is just being caught up in this weird, like, mass surveillance dragnet that just happens all the time, where machines get to just see everything you do, right? I'm like, that's just too much, right? So that's a really roundabout way to answer the question. And I would say that the answer really is, if you're a high-profile enough target, you will be caught, right? Like, they brought down Silk Road. A whole bunch of the darknet is actually going under this huge DDoS attack, and people are still trying to figure out if it was trade route exit scamming everyone, or if it maybe is. If it's the FBI, then it's really weird. It's not really their signature. They usually take down sites and put up a big thing that says, hey, we caught you all, haha. So rather than just like attack the whole network, like this seems to be going on right now. So yeah, that kind of gets to maybe what I should close on, which is, Tor is not going to be perfect anonymity. There's no such thing as perfect privacy. There's no such thing as perfect security. But again, it's the sort of mass online surveillance that we seem to have just accepted into our lives for some reason, that Tor and other privacy tech is really, trying to protect you against. And I don't see a need to kind of take it any further, like, oh my gosh, I want to make sure that, drug dealers and pedophiles can't get caught by the FBI. Like, no, they should absolutely be caught by the FBI, right? So that's it. That's the last question I have time for, but I'll be walking around if you want to ask me about stuff. I might have a plushie to give you for that. So thanks again.